In this video, I'm going to try to clarify the two properties from our notes, P.2, properties 5 and 6 about radicals that have to do with taking the even root of a negative number. So in property 5, we're taking the nth root first, and then we're raising the nth root to the nth power. So property 5 says the nth root of a to the n is a. That's what the property says. But we have an asterisk here, which is really saying, in addition, that if n is even, so we have an even root, then a must be greater than or equal to 0. Otherwise, this expression is undefined, because we can't take the even root of a negative number. So for example, if we had the square root of negative 10 squared, where first we're applying the square root, this is undefined, right? Because the square root of 10 is not a real value. It's not a real number. In property 6, though, we said that the nth root of a to the n. So here we're raising something to the nth power first. That's equal to the absolute value of a if n is even, and it's equal to a if n is odd. Okay, so what I want to focus on is what happens when n is even. So if n is even, then we need the absolute value of a. And let's look at an example of that. So if we have, say, the square root of negative 10 squared, what we're going to do is first we square negative 10. So negative 10 squared is 100. So this becomes the square root of 100, which is 10. And you'll notice that 10 is equal to the absolute value of negative 10. So if we have a variable underneath the square root, so let's say, for example, we have the fourth root of x to the fourth, that's going to be the absolute value of x. Now, actually, what I had in the notes was incorrect. I had a different problem. It was the fourth root of x to the fourth, and this problem is only defined for x greater than or equal to 0, because we're taking the fourth root first. We cannot take the fourth root of a negative number and then we're raising it to the fourth power. So this problem is like property 5 as opposed to property 6, which is what I was trying to illustrate.